So the question says that given A, B, C and D are four vectors and they are the summation of both of all the vectors are 0. So which of the statements are correct? So we have been given four statements. The first statement is A, B, C and D must each be a null vector. We all know that summation of vectors can result to 0. So they don't need to be they can be 0 independently, but they don't need to be 0 independently for the summation to be 0. So the condition of must here is false, because let us assume that this is vector A and this is vector B, and let us assume that this is vector C, and this is vector D. So we can see here that the summation of all the vector A plus vector B plus vector C is coming out to be vector D. They both have same magnitude. Now if we subtract vector D from both the sides, vector A plus vector B plus vector C minus vector D equals to 0. So we see here that they all had finite magnitudes, but still they resulted in 0 upon summation. So this condition is false, stating that they must independently be a null vector. Now let's just go to the second question. The question is the magnitude of A plus C equals the magnitude of B plus D. Now since the given relation is this, let us move forward with that. A vector plus B vector plus C vector plus D vector equal to 0. Let us subtract vector B and D from both the sides. So we will have vector A plus vector B plus vector C plus vector D minus vector B minus vector D equal to minus of vector B plus D. Now we see here that vector B and minus vector B is there, so they both will result to 0 or null vector. Vector plus D and vector minus D is there, so they will result in null vector again. Now the left out would be vector A plus vector C is equal to minus of vector B plus vector D. So the question was the magnitude of A plus C equals the magnitude of B plus D. We see here that since the both the sides are equal, so their magnitude must be equal, or since both the side of the vectors are equal, then the summation of A and C must have same magnitude to the summation of B and D. Now moving to the now this is correct, so we will mark it correct here. Moving to the next question, we have the magnitude of A can never be greater than the sum of magnitude of B, C and D. Now since this relation to be true, again we will subtract B, C, D from both the sides. Then we will have vector A equal to minus of vector B plus vector C plus vector D. So we see here that the magnitude of A is equal to magnitude of B plus C plus D for this relation to be true. So we can say that the magnitude of A can never be greater than the sum of magnitude of B, C and D for this relation to be true. Now let us go to the next question. This is true again. The next question says that B plus C must lie in the plane of A and D if A and D are non-collinear. So non-collinear vectors are the vectors having some finite angle between them. So let us assume that this is vector A and this is vector B and this is angle theta. So if theta is greater than 0, then it is going to be non-collinear vector. But if theta is equal to 0, then they both have same direction and they are said to be a collinear set of vectors. So the condition says that B plus C must lie in the plane of A and D. So let us pictorially represent this relation. Assume that this is vector B and this is vector C. Now B plus C would be somewhere like this, B vector plus C vector. Let us name this B plus C vector as M vector. Now we had relation A vector plus B vector plus C vector plus D vector equal to 0. This has to be true. We will see in the given condition. So the condition says that vector M must lie in the plane of A and D if A and D are non-collinear. So now we have vector M, vector A and vector D, and it is being said that they must lie in the same plane for this condition to be true. We all know that for a set of three vectors addition to be 0, they must lie in the same plane. So this condition is true because M now carries B plus C. So B plus C plus A plus D must lie in the this M vector must lie in the plane of A and D for this condition to be true. Now in the second part of the question it says that in the line of A and D if they are collinear. Now if A and D vectors are collinear, so let us assume that this is vector A and this is vector D. So now it is saying that the vector M must lie in the same line of vector A and D if vector A and D are collinear. So this is pretty obvious that the resultant vector will still have the same direction as that of A and D. So they must lie in the same line or same direction if this condition has to be true. So again the fourth statement is correct. Thank you.